Can we protect Mars from solar radiation? What happens in the cosmic voids? Would we have different astronomy if we lived in another part of the galaxy? And in our Q&A Plus edition, can we use the energy of Apophis to launch an interstellar probe? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. LDEK SOCH. For a deep field image, if JWST is kept in one spot far away, let's say 3 months or a long time, will that give deeper results? Absolutely. The Hubble Space Telescope used hundreds of hours of collective time over the course of many orbits to complete some of its deep field surveys. And so they stared at this one spot in the sky, and they were just, there were no galaxies in the region. And yet when they waited and observed and exposed for long periods of time, they saw that it was actually filled with galaxies, and it ended up being like 100,000 galaxies in this tiny part of the sky. And a similar thing will eventually be done with the James Webb Space Telescope. It just hasn't been done yet because this telescope is very, very busy. There's 10 times as many proposals put in to James Webb as there is time for the telescope to actually do the observations. And so setting aside the telescope for hundreds of hours to stare at one tiny spot in the sky is just not high enough on that list of priorities yet, but it will be. And so there are some really interesting surveys that are already being done today that are like mini versions of the Hubble Deep Field. One is called JADES. They're looking for the farthest galaxies that they can find. And the farthest one that they found so far, they're seeing the galaxy as it looked about 280 million years after the Big Bang. And in fact, there's a paper that we just reported on Universe Today where they're looking at galaxies that might be at redshift Z 15 to 20. And they think that they might be seeing galaxies that are at like 220 million years after the Big Bang. And there are a bunch of other surveys, SEERS, JADES, and there's a bunch of others. And right now, the people who are leading these different surveys are chatting and planning and organizing because they know that there will come a time when it's ready for James Webb to do its version of the deep field. And they need to figure out what are the right instruments to use, how long to use them, which filters to use, how should you calibrate your images. So a lot of the work they're doing right now is that they are learning how to use this telescope and how to gather the light and how to best work with the data as it is sent home. And once they're ready, then they will put in their proposal and there will be the version of the James Webb Deep Field, and it will be stunning. Already, James Webb has released images which are like mini deep fields. It can kind of just do a Hubble Deep Field whenever it wants with an hour of observing, even less. So when it does actually happen, it's going to be spectacular. Andrew Fisch. We live near a local void. Would astronomy be very different if we were located in a denser spiral arm? I'm not entirely sure what you're talking about us being in a local void. So the solar system is part of a thing called the local bubble. And this is a region of space that has a surprisingly low density of interstellar material around the solar system. So, it's about 1/10 the density that you would expect for the rest of the galaxy. And this is just particles floating around in interstellar space. And it's believed that this is caused because hundreds of supernovae went off in our vicinity a long time ago, and they cleared out this area. And so, yes, that gives us like a slightly less obscured view of the sky, a little bit less gas and dust, but not very much. I mean, the overall density, the amount of influence that's going to have on our telescopes is very low. But we are in a spiral arm, right? We are in the Orion spur. And so whenever we look along the plane of the galaxy, our view is obscured by the dust of the galaxy. And so the thing that would give us a much better view is if we were above or below the plane of the galaxy. Right now, if you want to look towards the plane of the galaxy, then you have the zone of avoidance, right? This area where there's just too much dust and there's nothing to see and there's no point to pointing your telescope in that direction. And so if we could be above or below the plane of the galaxy, then we could look over the galaxy to the stuff that's on the other side. Of course, then there would still be the core of the galaxy that we'd have trouble seeing through. We'd have to get really far away from the galaxy. If we were not in a galaxy, then that would be very helpful for astronomy. And gut 40. Is it feasible for us to eventually construct a magnetic field generator to place at the Mars L1 spot, thus protecting Mars? So if you wanted to fix Mars, if you wanted to thicken the atmosphere of Mars, the most efficient way that you would do it probably is that you would block the solar wind from reaching Mars. That it's the solar, like there is volcanic outgassing that's happening all the time on Mars. And so if you didn't let the solar wind hit Mars, then that outgassing would thicken the atmosphere slowly and steadily. And it wouldn't take long, like hundreds of years. And then you would get where the atmosphere could reach levels where, say, the carbon dioxide ice caps would sublimate and thicken the atmosphere further with carbon dioxide. And then maybe you get to this place where you could actually have the atmosphere thick enough to the point that temperatures would rise and maybe water could melt. So stopping the solar wind from hitting Mars should be job number one on your terraformer checklist. So how do you block the solar wind from getting to Mars? Well, there is this spot in between Mars and the sun called the L1 Mars-Sun Lagrange point. And that is the point where if you could put something there, then it would block the solar wind. So what kind of thing would you put there? And so one idea is you could put like some kind of solar sail, some kind of large structure. And as long as the shadow that it casts stays on Mars, then the solar wind is going to impact this shade. It's going to push it a little bit away, but as long as you balance the gravity, this thing is going to be able to stay in place. It's going to need some kind of propulsion. And then the other idea that has been proposed, that in fact you do have some sort of electromagnetic gadget that sits at this L1 Lagrange point and absorbs, redirects, blocks the charged particles of the solar wind so they can't reach Mars. Could we do it? I mean, if all of humanity put all of our gross domestic product into building this megastructure, maybe we could pull it off. Will we? Absolutely not. But it's fun to think about. It's time to shout out all the new $5 patrons. Sally Forth, Scott Williamson, Jacobs Loves Coffee, Ted P, TSC123, T Ben, David Woodland, Gregory Spear, Jenny Starstuff, and Cookie Eater 2009. Join the club at patreon.com/universe today. MrFuggdup. I'm wondering about the voids in our universe. If there are barely any stars there, would it be fair to assume that it's full of Bose-Einstein condensate? So these giant voids in the universe are the natural result that there is gravity, and that while the gravity is pulling the galaxies and the gas and such together into these giant structures at the largest scales, these giant walls and filaments that are the large scale structure of the universe, that has to then open up voids in between those areas. And over time, those voids are just going to get bigger and bigger and bigger. And like, imagine you have a piece of pizza dough, I guess, or slime, and you pull on it, and then you're going to get gaps and holes that open up in the slime, and more of it's going to be in your hands. So I guess that's the thing. And so the voids are the gaps that open up in between your hands, or when you're pulling the pizza dough apart. But you're asking, like, would it be full of Bose-Einstein condensate? No, I can't imagine that it would. I mean, it's going to be cold. It's going to be very close to the background temperature of the universe. But that doesn't mean that it's going to be Bose-Einstein condensate cold, which is just a fraction of a degree above absolute zero. And then there's other stuff that's involved to get it down to that temperature. So no, it's just going to be much less dense than the more dense parts of the universe. But when you look at the large scale, say you take a random part of the universe, just some random section, and you measure the density of material in that random part of the universe. And you pick some other random part of the universe and you measure the density of that random part of the universe, and you do this a bunch of times. The variations, like at some point you're going to hit a void, and some point you're going to hit a galaxy cluster. The variation between that density is about like 1 in 10,000. And it might be 1 in 30,000. I forget the exact number. So they are almost exactly the same, even though one is filled with stars and dark matter and galaxies and all kinds of stuff, and the other one is filled with what seems to be nothing. The actual density is very similar, and this is the large-scale homogeneity of the universe. So the universe is actually very similar, no matter where you go across the entire universe. Loololima. Have you had any currently Fringe experts on recently? Many of our biggest discoveries are made by Fringe people in their time. I have interviewed people who have gone on to be perceived as Fringe scientists over time. I don't want to name any names, but I've interviewed people who have, definitely their perception in the astronomical community has taken on more of a Fringe perspective. So I disagree that many of our biggest discoveries have been made by Fringe people in their time. That for a lot of the biggest discoveries, they come from people who deeply understand the current state of the scientific reality of whatever is the field that they're in, whether it's in quantum mechanics or whether it's in relativity, whether it's in physics, whether it's in biology, all that kind of stuff. That there is some knowledge, a scientific consensus of all of these people that have been doing all of this work. And a lot of the easy ideas have been tried and have been tested. And so it's really hard for a person to come in with a Fringe idea and say, maybe just, gravity doesn't work the way we think it does. And if we just follow my bubble theory of gravity, then this solves all of the problems and makes dark matter go away. And then a physicist can go, okay, show me the math. And you're like, well, I can't. And you're like, well, this is how we talk, is with math, right? And for us to be able to prove or demonstrate whether this thing is real. And if you can do the math, they'll go like, oh yeah, here's a paper. Here's 30 papers that came from out in the last 20 years where someone made exactly the same claim that you're making and it didn't pan out. And so the truly revolutionary ideas come from the people who understand the current state of the knowledge, and then they spot the missing piece. They make the cognitive leap to the next step, where that nobody had thought about this thing. And there are great examples. I mean, we can think about incredible discoveries like the discovery that the universe is accelerating, right? Dark energy. That's an observation-based discovery. But then you can talk about, was it the discovery of the bacteria where ulcers come from, right? That, this was a person who deeply understood the current understanding of how ulcers are formed, and none of the explanations really vibed with their theory, and so they came up with an out of the box idea for an answer that it's bacteria in your stomach that's causing ulcers, and then was willing to test it on himself. And so no, I don't think it's Fringe ideas that make a lot of progress. It is people who have dedicated their lives to understanding the current state of the field that they have specialized in. Once they understand all of the ideas that have been tried and rejected, this gives them a place to then look for the missing pieces and make progress. Laura Jervis, what is your dream interview? I get this question all the time, and hopefully this is an interesting answer, which is that I don't have any dream interview. I'm so fortunate that I've been able to interview anybody and everybody that I've reached out to that I've really wanted to talk to. And Partly that's because the people that I want to talk to are not celebrities, that they are very approachable, very easy to talk to. They are grad students who have just recently written a really interesting paper. They are engineering students who just worked on some really cool technology. They are astronomers who have just pitched a really interesting proposal for a new space mission. And nobody wants to talk to them. Nobody thinks that they're worth having a conversation with. And all of those other people are crazy because they are the most interesting people to talk to. So if you put in front of me a grad student who wrote a really interesting paper about primordial black holes and a celebrity, go ahead and pick any of the space related celebrities that you can think of. Which one would I choose? I'd pick the grad student. I would much rather interview the person who is doing this work, is thinking deep thoughts, is trying to express their ideas, wants to communicate this with a bigger world. They're the people that I want to talk to. And like, this is a thing that I've learned over time where I've been, in the past have, like many of you, gotten stars in your eyes. And I'm like, oh, it'd be so cool to talk to, I don't know, Neil deGrasse Tyson. And now I'm like, I don't care. I don't care. Like if Neil wants to talk, I'll talk. We've chatted in the past, and it's super fun, and he's hilarious. But I'm not going to reach out and try to fit into his busy schedule and put together an interview and all of that. I'd much rather interview people that I've never talked to, who I have no idea what their perspective is, and that they're going to teach me something new, and they're going to share their enthusiasm with space and what got them into this in the first place. So I don't have any dream interviews. And in fact, I scheduled one of my dream interviews for later on this week. And hopefully by the time you're watching this, I have already completed the interview, and we're going to be posting it probably within a couple of days. And that is one of the people behind the Vera Rubin telescope. So often my dream interviews are the people behind the scenes of missions, technology, ideas that I think are really cool. Those are the people that I want to talk to. And fortunately, nobody else wants to talk to them. So they're very easy for me to reach out to and conduct an interview with. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, could we hitch a ride on Apophis when it comes by? Link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who watched the show live and joined me for the 2-hour-long question show that we record every Monday somewhere in the world. So it's much longer, 2 hours. We have a great chat back and forth with the people who are watching the show, and we get to dozens and dozens of questions. I know this only feels like we got a couple, but we do many, many more. 50 plus questions during the full live show. I'm going to give a shout out to some of the people on the team, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barry Lake Roofing, Brian Bodie, Carolyn, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Heinz Schultz, Hudson Moore, Jay Graves, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Modso, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler-Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I know Universe Today feels like it's me, or like all of this space reporting that's going on is just coming from me, but that couldn't be further from the truth. We have a huge team at Universe Today that are working on all of these stories. And a lot of the stuff that I'm knowledgeable about is because we have reporters who are reporting this stuff over on the Universe Today website. And one of the things, like I have these interviews with the patrons, and a lot of people sort of, when they find out, they found me through Astronomy Cast, and they didn't realize that my main job is that I am the publisher of Universe Today. That is my day job. I am not a YouTuber. I am a publisher of a space news website, and we've got a great team over there with decades of experience in space journalism, many of them who have PhDs in astronomy and astrophysics. So I want to give a huge shout out to the team over on the video side. Of course, Chad and Anton, who edit the videos. Chad is the one who edited this video, and Anton is the one who edits the interviews and Space Bites. And then the writers.
Dr. Brian Koberline, Dr. Paul Matt Sutter, Carolyn Collins Peterson, Evan Goff, Matt Williams, Lawrence Tugnetti, Mark Thompson, man, it goes on. And, you know, Alan Boyle, Alan Versfeld. So it's kind of amazing how much of a team we've got who have been reporting on this stuff for a very long time. And that, you know, they're able to go and actually investigate the individual stories and write them up and prepare them. And then I can report on their reporting when I do Space Bites and when I write my newsletter. And it's absolutely an incredible team. I couldn't be more grateful for the quality. And now that we are fully 100% Patreon supported, we don't have to worry about advertisers, search engine optimization. We don't have to worry about AI algorithms. We don't have to worry about any of that. We just can report on space news, and it feels really good. The level of freedom and independence that I have and that I'm able to sort of pass along to the team is incredible. And yeah, it's amazing. So anyway, for those of you who are patrons, thank you. For those of you who aren't, this is for you. Enjoy. It's all free. Copyright free. Go crazy. All right. Thanks, everyone, and we will see you next time.